If you followed my previous architecture guide, you'll see that I use a mixture of provider and get it for my application architecture. There's three main reasons for that. The first is injecting or retrieving dependencies where the build context is not available was difficult. The second one is that the code for dependency injection using provider only has more boilerplate associated with it. The third one can be considered good or bad depending on your coding principles. The third one is that the dependency injection code for the provider only architecture is aware of where the injections are happening, and it requires you to always update your signatures of the constructors if your dependencies change. Those three things can basically be summed up by saying that Getit is easy to implement, maintain, and understand. That doesn't mean that it's all good, and I've discussed the cons of Getit in my previous video. So with the release of Provider version 3 comes a new provider called ProxyProvider. ProxyProvider is a provider that builds a value based on other providers. What this means for us as Flutter architects is that we can now inject providers into other provider values. In this tutorial, we will build the same app as we did with my original architecture setup, the only difference being that there will be no Getit this time. Before we start building the architecture, I think it's important to define and outline what you want this architecture to achieve. And that's outside of the basics like maintainable and easy to understand and well separated. While developing using this architecture, there's a few things that we'll keep in mind. The first one, which I don't think I made clear in the last video, is that for every group or collection of widgets that relies on its own logic, we'll put it in its own widget and it will have its own view model. This will be to combat the fact that when you call notify listeners for small changes, the entire view won't re-render. If a view has a model, the only purpose of that model will be for functionality that it's shared between all the widgets, but the main purpose will be to show different states of the UI. The view will act as a high-level document that says, show this when it's in this state and show these widgets when it's in the other state. The third point is that there will be no business logic in the UI file. I consider the UI being the file that defines the widgets and the layouts of the widgets. The view model is not a part of the UI. The fourth one is that all logic and state management happens in the view model. And then we also want to make sure that the view model does not implement any specific functionality. I know it sounds weird, but instead of the view model implementing all the functionality, we'll put it in a shared service that can be used with multiple view models. We'll create dedicated services that group functionality together based on the app's requirements. We'll use the single responsibility to a moderate degree when it comes to this. Even when it comes to something as simple as the single responsibility principle, there's still extreme versions of it, and that's not the one that we want to implement. Some people teach it in a way where they say that every class should only have one function because that will keep the responsibility of that class very simple. Instead, we'll use it based on this quote from one of the founding fathers of this principle. He said, "Gather things together that change for the same reasons. Separate those things that change for different reasons." And based on that quote, we'll create dedicated services to do all the actual work. And one of the last points is that models will reduce state based on the information in the shared services. If you'd like to follow along, head over to fieldstacks.com. There's a full written tutorial, and you can also download the starting project code as a zip file. There's a few things that I've set up in the starting project just so that we don't focus on anything other than the application architecture. Here's a list of everything that we've added. Just to cover some of the things, I've added the colors, API class, an authentication service that uses that API class. I've added empty home views and some widgets, and I have also set up the routing based on one of my previous tutorials on my website. So getting into the code, we can just start by adding the new provider version 3. We'll start with the reason why everyone is here, and that is to see how we can do the dependency injection using the new ProxyProvider. Using the multi-provider, we will create a dependency injection hierarchy that we can use throughout the app. So we'll start by wrapping our entire material app with a multi-provider. This takes in multiple providers that will be exposed to the app through the provider.of call. Then to set up our providers, we'll create a new file under lib called provider setup. Let's go over two things that you need to understand if you want to effectively perform dependency injection at this point. The first thing is that you can only inject a service that has already been supplied as a provider. And the second one, which is the same as the first one, is that the order of registration matters. With those two things in mind, we'll have specific lists for each of our providers that make it clear when they are registered and where they are provided, in the case of UI consumed providers. To keep our provider architecture clean, we'll have 4 different lists. We will have our main list of providers, which is a list of single child clonable widgets. Then we'll have a list of independent services, which will be classes or objects that does not depend on any other services to perform its functionality. Then we'll have a list called dependent services. You can call it dependent providers. Either way, these are services or classes that depend on the previously registered providers. And then the last list will be UI consumable providers. Now we can use the new spread syntax and we can add in all of our lists into the main providers list. We'll use the simple spread syntax to add the independent services first, then our dependent services, and then our UI consumable providers. Then in the main file, you can now supply your providers with the providers from the provider setup file. Let's start with the dependency injection. In this project, we only have 2 services or functionality classes. I don't even know what to call it, what the proper word is for it. But we have the authentication service, which is dependent on the API. And the API has no dependencies. So to make sure that the API is available to the authentication service when it requires it, we'll start by registering the API. Go to your independent services list and we'll register a new provider using the provider.value named constructor. We'll pass in the API value. Then for your dependent services, we'll use the new ProxyProvider. And the way that this works is that your first generic argument, you tell it what provider it depends on. And the second argument, you tell it what type of provider to return. So we'll pass in the API and the authentication service. And in the builder now, you'll get your build context, and then you'll get the API provider value, and you'll get your initial authentication service value. We can then use this to construct our authentication service and then pass in our API. If you want the authentication service passed in to have a value as well, you can set up your initial builder and perform some additional logic there if you want to. And that's all we'll need to set up the dependency injection. And next up, we'll do the view models injection. We'll build the application from the first view, which is the login view, until the last view, which is post view. So we'll start with the login view. So under the core folder, we'll create a new folder called view models. And inside that folder, we'll create a new folder called views. And in there, we will create our new file called login view model. The login view model will be a class that extends the change notifier. It will depend on the authentication service, which we'll keep private. And we'll inject that authentication service as a required name parameter through the constructor. We'll pass in the authentication service type, and then we'll set our private value equal to that value passed in. This model will also have a login function that returns a Boolean future and takes in the user ID as text. And as mentioned before, we always want to show the user what's happening, so we'll create a busy indication for the user. We'll keep a private Boolean value called busy, and we'll expose that value through a public property called busy. We also know that whenever the busy value changes, we want to call notify listeners. So we'll create a function called setBusy that takes in a Boolean called value, and in the function we'll set that value equal to the private busy variable, and we'll call notify listeners. Now for the login implementation, we can start by setting busy to true, and then we'll try and pass our user ID text, and then we will call the authentication service login function with our new user ID, and we'll await on that value. When that's complete, we want to set busy to false. Then we want to return the Boolean of success to the outside caller. To make use of this model, we will go to the login view. So as an example of having a login model, we'll wrap our entire scaffold with the change notifier provider. Before you get concerned, this architecture won't re-render the entire view based on a small change in the UI. It's more thought out than that, and if you follow along, you'll see later on that your UI will not be re-rendering continuously for small updates. We'll use the .value named constructor of the change notifier provider and give it a type of the login view model. For the value that we want to supply, we'll give it the login view model. And then the root of our child will be a consumer of type login view model. Then we just want to update the code. So instead of passing the scaffold as the child of the consumer, we want to return it as the builder function. So this is where the dependency injection into the view models actually happen. So pay attention. So here we have to provide the authentication service to the login view model. And to get the authentication service, all we have to do is call provider.of_context. Dart has some good type inference, so we don't need to actually give the type. The provider will figure it out and provide the correct type. So it's not as bad as I thought at first. And that'll be the pattern we'll follow for all the models. You always have to update your signatures, and when you update your signatures, you have to come to your views where you inject, and you would have to add the new ones or remove the old ones. Now we can go ahead and build the UI for the login view. This is how we want the login view to look. So we have the widgets and we'll just start building. The body of the scaffold will be a column. The first child will be the login header, and the second child will depend on the model's busy property. If the model is busy, we want to show a circular progress indicator, and if it's not busy, we want to show a flat button. The color of this button will be white, and we'll give it a child that is text of login, and we'll give that text a style so that the color is black. We need to take in text input, so for that we need a text editing controller, which means we need to convert our login view to a stateful widget. Then we can add our text editing controller at the top, and we'll pass that to the controller value of our login header. The last thing to do is to hook up the login call from the model to the onPressed call from the flat button. We'll call login and we'll pass the text from the controller, and we'll await on the login success. If the login was successful, then we'll push a named route and we'll go to the home view. I've set up some constants called route paths, and it contains home, posts, and login. When you use the consumer widget from the provider package, you have the option of providing a pre-built child. This child will be returned to you through the builder of the consumer, and it will never be rebuilt after the first build. So we will take our login header and we'll supply it as a child to the consumer. And then in the builder function, we'll put the child at the top where the login header was. This is a small optimization, but can have many benefits based on how your UI is set up and when you require things to re-render. So as you see here, there's about 5 lines of code associated with setting up a widget with its own model. Since we know that we'll be building many widgets and views with its own model, we want to make this process easier and wrap it all into a single child. So we'll create a new file called base widget that will wrap all of this functionality and make it easier for us to provide models to our widgets. The base widget will be a stateful widget named base widget. It will be generic and will take in a type that extends the change notifier. You have to make sure that the type is passed in wherever it's required. So the base widget state needs to have type that extends the change notifier, and that type needs to be passed in from the base widget down to the base widget state. So based on the code from the login view, we know that there's 3 things that we have to pass into our provider and our consumer. The first one is a function that returns a widget and that takes in our build context. It takes our model as well as a child, and that will be our builder. The second thing we have to pass in is the actual model, and the last thing we have to pass in is that static child that we spoke of earlier. For the model, we want to keep the model instance in the base widget state to make sure that we retain the same instance that was passed in originally. We'll set this instance in the init state override, and we'll just get the model from the widget. The root of our build widget will be a change notifier provider of type T, and we'll create that using the named value constructor. The value we'll pass to it is the model that we keep locally, and the child of that change notifier provider will be a consumer of type T. The builder will be the builder directly from the widget, and the child will also be the child directly from the widget. Now back in the login view, you can remove all the code for the change notifier provider and the consumer and replace that with a single base view widget call and give it the type of login view model. The next piece of functionality that we know we have to share with all the models is the busy functionality. We'll create a base model that we will use to inherit from, where we can get the busy functionality. We'll create a new file under the view models folder called base model, and it will be a class that extends the change notifier. We can then go ahead and move all of the busy related code from the login view model to the base model. And the last thing to do is to extend our login view model from the base model. Next up, we'll implement the home view. To stress the importance of building widgets with its own model, we'll implement the home view without a model, and we'll handle all the responsibility of fetching posts to a new posts widget. One of my goals is to keep my views in a way that it always reads like a high-level document. The post widget will define its own model and then also take responsibility for fetching the posts given a user ID. This way, this widget is actually reusable and decoupled from any place where it's being used in the app and can be used on any view and in any layout. Building actual reusable widgets using this architecture is actually very important now, given the fact that web and desktop is on the brink of being an actual reality. This means that you'll have multiple layouts using the same widgets or the same functionality, and having something as easy as this to just move around will be a lifesaver when you are building new layouts for different size devices. Before we start with the home view, we know that we'll be using the user details on every view going forward. Head over to the provider setup file. We will provide a new stream provider of type user, and in the builder we will get the authentication servers using provider of, and we'll return the user stream. Now, because of providers need to update dependencies that providers depend on, we have to set the listen value to false. This is the only way that this will work, and it is to indicate that our stream provider should not be updated based on a new authentication server's value being provided. Now that that's available, we can start with building the home view UI. We'll make the body of our scaffold a column. We can set the cross-axis alignment to start. Then our first child will be a vertical large space. The second child will be our title that will say welcome, and it will display the username from the provider stream that we just implemented. We'll give this title some padding on the left of 20, and we'll set the style of this title to header style. The second child will also be some padded text, and it will be of style subheader style, and it will just say, here are all your posts. The next widget will be a small vertical space. And lastly, we want a widget that takes up all of the space in the column. So we'll give it an expanded widget, and the child of that widget will be the new posts widget that we'll create shortly. In the UI folder under the widgets folder, create a new file called posts. This will be a stateless widget called posts. We know that this widget will have its own model, so the root of this builder function will be a base widget, and we'll give it a type of posts model. Then in core under the view models folder, you can create a new folder called widgets, and in this folder you can create a new file called posts model. This will be a class that extends our base model. The model will depend on the API, and we'll provide that API as a required name parameter through the constructor. We can then set our private API value to the API passed in through the constructor. This model will contain a list of posts, and it will have one function that returns a future, and it will get the posts based on the user ID passed in. The first thing we want to do when we call this function is to set busy to true, and the last thing we want to do is set busy to false. Then we can go ahead and fetch our posts from the API using the get posts for user and passing in the user ID. That's all the logic for this model. Head back to the post view and import your posts model. For this posts widget, we know that we want to call the get posts function on the model as soon as it starts. This functionality will be required for multiple widgets, so we'll build it into the base widget. We'll add a new function that takes in a type t as a parameter, and we'll call it onModelReady. We will then pass that function in through the constructor, and in the init state override we'll check if this function is null, and if it's not null, we will execute this function and we will pass in the model instance that we are keeping locally. Now back in the posts view, we can pass in the model, and we'll inject our API using the provider of call, and additionally we will pass in the onModelReady function, and when this function is called, we want to call get posts and pass in the user ID. Then we can go ahead and supply the builder for the UI of this widget. We will check if the model is busy, and if the model is busy, we will return a centered circular progress indicator. If the model is not busy, we will return a list view that we'll build, and the item count we'll set as the length of the posts property, and for each item we'll return a posts list item. We'll pass in the post using the index, and on tap we want to push a named path using the route paths.post, and for the arguments we'll pass in the post by indexing into the posts on the model. It seems that I've made a mistake, so you can go ahead and set the default value of the busy boolean to false. One other thing that I forgot is in the login view to set the column to align the children to the center. If we run this app now and you enter a number between 1 and 10, if you select the login, you'll get to the home view, and then you'll have the post widget that will fetch its own posts and display all of it. The last view to implement will be the post view. To keep the theme of expressing the fact that each widget can have its own model, we will create the post view without a view model. The comments widget will be responsible for fetching all of its own data and displaying it as a list. We'll set the body of the scaffold for the post view to a padding child so we can add padding around the entire UI section. We'll set the padding to horizontally be 20, and the child of this padding will be a column. We'll also make sure that the cross-axis alignment is set to the start so that everything is aligned to the left. The first child will be a vertical space large. The second child will be a text widget that displays the title of the post, and we'll set the style to header style. And then we'll follow up with another text widget and we'll display the username of the user. For the font size of this text, we'll just set it to 9. Then we'll add another space, this time a medium vertical space. We'll show the body of the post, and the last item in our column will be our comments. The comments expects the post ID, so we'll pass that in as well. We've already made the comments UI file, so you can just navigate there, and we'll start with a UI for the comments. Since we know that the comments will have its own view model, we can just return the root of the build function as a base widget, and we'll pass in our comments model. Then under the view models widgets folder, we create a new file called comments model. This class will extend the base model, and it will depend on the API which we will inject through the constructor. And similarly to the post model, it will contain a list of all the comments. And this model will also only have one function called fetch comments that takes in a post ID. We'll indicate that the model is busy at the beginning and at the end. Then for the actual work, we will just call through the API to get the comments model passing in the post ID. Now back in the comments view, we can supply the onModelReady function, and when the model is returned, we will call fetch comments and pass in the post ID that we passed through the constructor. For the model, we'll pass in the comments model, and we'll get the API from the provider. And the last thing to do is give our builder so we can define our UI, and the UI will be very simple. If the model is busy, we'll return a circular progress indicator in the center of the screen, and when it's not busy, we'll return an expanded child so it fills up the rest of the screen, and that child will contain a list view where the items are built from the comments on the model. And for the item builder of this list view, we will return a comment item, and we'll pass in the comment for the current index. And that is basically the entire app complete. And if you go through it now, you'll be able to log in and you'll get your user, which is displayed, and you can view your posts, and the comments are fetched by the comments widget. So building the app like this, you can actually just move these widgets to a different view and it would almost make no difference. You would just have to figure out how to pass in the data that it wants. But other than that, there's no dependencies on the outside, and it runs completely on its own and fetches its own logic and handles itself. The last thing we want to do is handle our dispose, and as you can see within the change notifier provider, the disposer will call the notifier's dispose, and that value is only set through the default constructor. So to see that this works, we will override the dispose function in the comments model, and we'll just print out something like I am disposed. Then in the base view, instead of using the value constructor, we will now use the default constructor, and we will pass in a builder that then returns our model. Now if you log in and open up a post, when you navigate back, you'll see that it prints out the I have been disposed message that we set up in the disposed call. And that's it for the architecture. I think I expressed the fact that we have to keep our responsibility single. That comes for the UI and for the models, and as well as the services. If you stick to those rules, you can build any size app and it will be maintainable for a very long period of time. The architecture is not bad at all. The only thing that I have a concern about is the fact that your signatures will always have to update, which can be good or bad depending on how you look at it, and the fact that you will always have to update your dependency code based on what you are changing in your current services or your models. If you inject more things, you'll need to go update your code. Thank you for watching. I really appreciate it. Please share this video and like it, and if you haven't subscribed already, please subscribe. Thank you.